Bonjour, and thank you. I apologize that my French is not proficient, so I will speak in English. I apologize. Can I have sound? Sound? Thank you. It is an honor to be here, and thank you, organizers, for inviting me. It's an honor to be on this panel with distinguished presenters. Brandon, thank you for your really nice talk. In fact, I'm going to pick up on some of the points that you made. The title of my talk is Challenging Assumptions About Drugs. Now, one of the things that I notice when I come to these types of conferences is that many of you all, physicians, healthcare providers, do really good work, and your heart's in the right place, particularly as it relates to studying drugs and treating drug addiction. One of the things that I would encourage all of you all to do is to broaden your perspectives on what drug users look like. We all tend to work with people who meet criteria for drug addiction. But the vast majority of people who use these drugs are not addicts, and they behave somewhat differently. So keep that in mind as you think of this. I'm going to talk specifically about methamphetamine today and use that as an example of some of the assumptions that we make about drugs and those assumptions being incorrect. But before beginning, I just want to show a quick clip of some drug education in the U.S. as it relates to methamphetamine.
This isn't normal. But on meth, it is.
This was a popular advertisement campaign in the U.S. as it related to methamphetamine to try to help people understand what methamphetamine does. The problem is that it helped to vilify the drug, and more importantly, what it proposes or that the drug do is probably inaccurate. Certainly based on evidence. So what I want to do today is to challenge two assumptions made about methamphetamine, but instead of doing like a lot of folks using anecdotal information to challenge these assumptions, I like to use some data. And those assumptions that I like to challenge today are that methamphetamine has a unique pharmacological profile, like there is no other drug like methamphetamine, or the other amphetamines behave differently. And the second assumption is that related to this idea, this notion that methamphetamine causes all of these cognitive impairments. Before doing so, however, I'd just like to briefly talk about a study that kind of got me involved or interested in methamphetamine. And so keeping with the theme of the conference, seems like safe injection sites, instead of a safe injection site, we have a laboratory in which we bring people in and we administer various drugs, including methamphetamine, to try to carefully evaluate what happens after someone has used those drugs. These studies are rigorous. They are within subjects, placebo-controlled, highly rigorous. Just quickly, I'd like to share the design of one study. This slide shows that in our lab, one of the things that we do is we alter the time at which participants are scheduled to wake up. These people live with us for about from 2 to 4 weeks, and while they're with us, we have them complete cognitive batteries as part of their work performance. And they do this for about 8 hours. And as we change the shift or the time at which they wake from, sometimes they're awoken in the morning and sometimes they're woken in the middle of the night. And when you shift people's work schedule, you can get some disruptions in cognitive function. And that's what this slide illustrates. It simply illustrates that when people are on the day shift, here in the circle, and here's when they're on the night shift. It simply illustrates that you get disruptions in response time, learning and memory, and also inhibitory control. It's a simple sort of graph. I don't want to focus too much on it. But the point is, when you do this, you can give drugs to see if you can alter the performance or attenuate these disruptions. And this is an earlier study that I published along with some colleagues. And the bottom line, what we showed was that when you administer a drug like methamphetamine, low oral doses, you can attenuate these disruptions in response time, learning and memory, and inhibitory control. This is not a surprise. Militaries all around the world, for some of their soldiers, they administer amphetamines, particularly those folks who might be subjected to fatigue or sleep deprivation. And amphetamines are effective medications, given at low oral doses. And then when you look at the literature, you can also see when you give these drugs, methamphetamine, at low oral doses, you don't see the disruptions that people or that the anecdotal sort of reports suggest. And so this got me to thinking about, well, maybe what we are saying about the drug is not accurate. But there are some caveats to the studies that have been published, including my own. Relatively low doses is what we use, and also the route of administration in the past have been primarily oral. And so we have to keep those things in mind. But as I thought about those limitations, I went about studying the drug at larger doses, giving it in a route or via a route of administration that drug users or drug abusers use the drug, intranasally. So one of the more recent studies that we published, we compared methamphetamine to D-amphetamine given at large intranasal doses. And what you find is that when you look, let me orient you to the graph. This graph here shows you systolic blood pressure. On the y-axis, you have the dependent measure here, and on the x-axis, you have the doses. In this light green, you have D-amphetamine at a low dose, 12 milligrams, and methamphetamine in the darker green, 12 milligrams. In the light red, you have a large dose, 50 milligrams of D-amphetamine, and in the dark dose, 50 milligrams of methamphetamine. The bottom line here is that both drugs produce the same effect on systolic blood pressure, on subjective effects, on high euphoria, and they also produce the same effect on when you allow people, these methamphetamine addicts in the lab, to self-administer the drug, they take the drug at the same rate. The bottom line is that we have known this with oral methamphetamine. There were a few papers published with oral methamphetamine up to 50 milligrams. Back in 1971, Billy Martin published this, and then in 2009, Craig Rush's lab did a similar sort of thing with oral methamphetamine. But these are the first data that looked at large intranasal doses. And the bottom line is this. The notion that methamphetamine has a unique pharmacological profile is just simply not supported by evidence. It's the same drug as D-amphetamine. Okay, but despite this sort of similar effects and also this sort of similar chemical structure, this is D-amphetamine here. You add the methyl group, that makes it methamphetamine. But despite these similarities in terms of effects and also chemical structure, medical methamphetamine has been banned in the UK and in New Zealand, and a growing number of other countries are moving to restrict medical methamphetamine. Medical methamphetamine is available in a number of countries, including the US, for treatment of attention deficit disorders, obesity, narcolepsy, and also military use. But the point is that concern about methamphetamine being unique has caused some countries to ban the use of this drug. But that concern doesn't seem to be supported by any evidence, but it's primarily anecdotal evidence that's driving it. Another concern or another assumption is related to methamphetamine's effects on cognitive impairment. As I said, there weren't many studies that looked at larger doses of methamphetamine administered to humans. And so since that was the case early on, I reviewed the animal literature to try to find out what were the effects of methamphetamine at large doses on the brains and cognitive function of laboratory animals. What you see is that methamphetamine clearly produces neurotoxic effects on monoamine-containing neurons, serotonin, dopamine, norepinephrine neurons. It also disrupts cognitive functioning in multiple domains, including memory, sequential learning, and so forth. But there are caveats to those findings, and these caveats have often been ignored or left out when people talk about the effects of methamphetamine. These deleterious or negative effects on the neurobiological changes and cognitive changes can be prevented if you administer methamphetamine in escalating doses, allow the animal to become tolerant to some of the effects of methamphetamine. You can prevent all of these neurobiological changes as well as cognitive changes. There's also this important consideration. When you allow the animal to self-administer the drug themselves, you also prevent these cognitive changes or neurobiological changes. So this really underscores the importance of animal researchers to use ecologically valid or ecologically relevant models when you think about methamphetamine. So the bottom line is that, again, when we think about the cognitive consequences and the neurobiological consequences of methamphetamine administration, the animal literature simply didn't support what people were saying when you use the appropriate controls and the appropriate models. All right, so what about humans? And an important question that I had as I continued to do this work: what happens to the cognitive functions of humans when you give them large intranasal doses of methamphetamine or large intravenous doses of methamphetamine? What happened to their cognitive function? This is just a slide that summarizes all of the literature that has done that has given the drug at doses larger than 20 milligrams via routes such as intranasal or intravenous. And what you find is not disruptions, what you find is that the drug improves performance in multiple domains. Again, these studies were done in carefully controlled laboratory settings. It still remains what happens to people who have abused the drug for many years. What happens to their brains? That's an important question. What happens to the brains of drug users, of methamphetamine users, long-term methamphetamine users? I was interested in this question, and so last year I published a critical review in neuropsychopharmacology that addressed this particular issue. Now, this is just a slide of one of the studies. This is a representative study, a PET study, that looked at binding of at the monoamine transmitter. The monoamine transporter. In the triangles, you have the methamphetamine users. In the circles, you have the controls. When you look throughout the striatum, you see that methamphetamine users here have slightly less binding potential than the controls, about 10 to 20% differential binding potentials. And this is pretty consistent when you look at the PET literature. There's about a 10 to 20% difference in terms of binding. Now, what that means, we don't know exactly, because we don't know if the lower binding potential were there before people started to use the drugs. It's unclear. But one of the critical questions that we needed to ask was, does this have any cognitive consequences? Does this impact cognitive function? And that's an important sort of role of the brain, cognition. So that was one of the questions that I addressed in this critical review. And in my sort of review of the literature, one of the things that I discovered was that most of the people who do cognitive testing don't include the appropriate control. For example, whenever you test people's cognitive performance, the cognitive performance of the group of interest has to be tested against individuals who are of the same age and of the same educational level. If you don't do that, you can't make conclusions about their cognitive functioning. You can't make appropriate conclusions. As I reviewed the literature, only one study that actually did this appropriate control found a difference between methamphetamine users and the controls. That was one study done in 2003. That study has yet to be replicated, even though a number of people in the literature claim that methamphetamine users are cognitively impaired because they may have seen some significant difference on one test or two tests out of 20. Even though there is a significant difference, the methamphetamine users were still performing within the range of those individuals who are the same age and the same educational level. So inappropriate conclusions have been made. All right, a summary of what I've said in terms of the cognitive findings. When you give the drug in the lab, even at large doses intravenously or intranasally, methamphetamine improves cognitive functioning. When you look at the data from the PET studies, there's a lower density of dopamine transporter binding and monoamine vesicular binding as well in the methamphetamine users, 10 to 20% difference. That difference doesn't seem to mean anything in terms of performance, cognitive performance. When you look at the MRI data, the fMRI data, there are a lot of differences that have been reported. None of these things have been replicated. And the meaning of these differences, we don't know because there are no cognitive correlates to go with it. So what does this situation mean? What's the implications for this situation? As we look at the science, from a scientific perspective, if we go in with a biased perspective, this decreases the likelihood of us documenting the actual pattern of effects that's caused by the drug. And as we think about treatment, there has been some talk about methamphetamine users, for example, not being able to benefit from arguably one of the most effective drug treatments, cognitive behavioral therapy, because they are cognitively compromised. That is simply not supported by the evidence. From a public policy perspective, several governments have taken moves to drastically decrease or limit the availability of methamphetamine. In Thailand, for example, in 1996, they have banned all amphetamines for medical use because of their concern about how dangerous the drugs are. In the U.S., we punish methamphetamine infractions more severely than anything else other than crack cocaine. And then our views about this drug actually feeds into this notion of a war on drugs, which that's not the focus of today's talk, but I'm happy to talk about that in the discussion. Now, I want to make sure that I don't leave you all with the impression that I am minimizing the potential harms associated with methamphetamine abuse, because I am not. I understand that methamphetamine can cause some serious functional problems, particularly for those people who are addicted. That's not the goal of this presentation, to minimize those findings. The goal of this presentation is to ask you all to make sure that your beliefs about methamphetamine and other drugs have foundations in real evidence. That's the goal of the presentation. And I'd like to leave you all with these take-home messages. That many of the assumptions made about methamphetamines are simply not supported by evidence from research. However, these assumptions allow us to vilify drugs, and they show us how we can create a worldwide drug menace, if that's our goal, and I don't think that's our goal. Our current knowledge about the drug, of course, is incomplete, but we're still, as a society, as responsible society, we are still required to provide treatment, provide education, and public policy surrounding these drugs. And sometimes we make mistakes, and that's okay. The key is to make sure that we're able to alter our actions as new and more complete information becomes available, and as this knowledge would dictate. Finally, please use your common sense when you hear stories about drugs. If the story seems incredible or seems outrageous, it probably is. And I thank you for your time.